You had some code listings to turn in. So hopefully you get the idea of what's going on here. Now, up to this point, we've used data types that were created by the program, whoever created C++. And those data types, we've used included int. Oh boy, that's not very good, is it? Shiny and on and on. Int. What other data types do we have?
Double, float,
Yeah, double and the float. We have Boolean. We have
string.
string. We have char. So we have a whole bunch of data types. Okay. String was actually from a class. It was an object because it came with a whole bunch of methods. So it's a little bit different than the primitive ones, but these all fit into the category of data types. Well, just like our objects from way back as another data type, we created objects of a class, and inside of that class, we were able to have a couple of different fields. And also inside of there, we had methods that worked on that. Well, today we're going to look at a new data type. Again, it's going to be created by the programmer like an object was, but it's going to be used simply to store a bunch of different data types within it. We don't have all the methods and things that went along with objects, but it's just going to be similar to that, but only storing data. Okay, so these guys are all called abstract data types. When you move on to CPS 162, the whole course is creating abstract data types, queues, binary trees, stacks. And it's kind of an interesting course, but you're going to be able to store different things within your data type. And the one today, a struct, becomes a big part of that. Okay, created by the programmer, own range of data. So it's different data types, unlike an array, which was all the same data type. This is different data types. And when we want, we could have a set of operations to go with it. And that's what I just mentioned a moment ago about creating an object of a class. We could have operations to go along with it. Well, the data type that we're going to look at today is one called a struct. And if you did the code listing, some of you are feeling pretty good about it because it's understandable, easy to work with. But in a structure, what we're able to do is create something like the good old days when people on their desk had something called a Rolodex. And a Rolodex was a bunch of little cards, a bunch of little pages like this. And then on the first one, usually these were sorted alphabetically. So on each one of these, you might see something like name, address, phone number, city, state. And then the next one would be the next one. And they'd have holes punched. So in the old days, we could look at each one of these, and some instances you'll hear them called records. We could go through the Rolodex and find what we want. But each card of the Rolodex had certain things on, certain pieces of data, certain data types. So a structure, one way of thinking of that is it's like that old Rolodex where I can create a data type that holds different data types. Okay, the data type is called structure. When I go to declare it, I type in the word struct, as you know. I give it a tag. The tag is now the name of that data type. This example here, it's employee. So I would create a new variable of type employee, just like I did int, just like I did double, like I did with my objects. Okay. I don't know why I said okay, because nobody's going to answer me anyhow. When I lay it out, I give it the tag name. I have a left brace, a right brace, and that semicolon. Easily could be forgotten. Okay. But that semicolon appears at the end of my structure. An example, I'm going to create the new data type called employee. Employee is going to have three things in it. One is going to be the name, which is of type string, age, which is type integer, and address, which is also of type string. Now, when you get to 162, oh, puberty, yes. When you get to 162, one of these is going to be a pointer, which is a data type we learned about, holds the memory address. So we're going to make a big use out of structs and pointers. Ah, I'm intrigued. I can't wait till I can sign up for CPS 162 and get to August really fast, skip summer, so that I can find out more about these linked lists. All right, in order to use the elements inside of, well, not elements, it's actually called a member. Sometimes I say field by accident and I shouldn't. In order to get to it, we need to take the name, follow it with the dot operator. Okay, and down here below, one of the things we can't do is I can't take circle 1 and see if it's equal to circle 2, because that's only going to check addresses. What do I need to do to see if two structs are exactly the same? I need to see if their radiuses would be the same. I need to see if their whatever is the same, and on and on and on. All right, so I have a note, code listing 11.1. Looks like one that you did. And if I throw it up here, I have a struct payroll. There's that stinking semicolon. I have all of my members. And when I get ready and I want to use one, C in employee, employee's data type is payroll, and I can go to employee.emp number. Okay, actually kind of a long example, but yeah, that's what we got to. When I create a struct and I want to get ready and fill some of the data, fill some of the members, I can fill them right away. And I don't know if you want to call this implicitly, like we filled arrays implicitly, but it's the same kind of idea. The only thing is we have nice options. I can create a new variable city of data type city info, and I can store something in the first member. I can store something in the first 2 members, or I can immediately store something in the first 3 members. So if I wanted to initialize the values right away, and again, I know I didn't see it called implicitly or not, but I can assign values right up front.
I have a question.
Yes, Janae.
What if you wanted to just skip the first value and go straight to the second? Would you just put empty brackets and then do the second, or would you do city dot state?
I would recommend you do city.state. Yeah.
Thank you.
Yep. Good question. Array of structures. This is actually section 11.5. Believe it or not, we've just covered 4 sections. But I think you have a pretty good idea of what's going on. So going back, I still have my city information. I declare as my data type. I start with, now all of a sudden I'm declaring an array variable instead of just a single variable. Syntactically, that's really all you need to know. Where does the square bracket go? City sub 0 dot name goes to Harrisburg. City sub 1 dot state goes to PA. So I could really just go through and fill in all the individual elements of the array. So really I have, however many members there are in city info, and 3 from times 3. So I would have that many places to store data. And again, I think, you went through, you did a bunch of code listings, and everything worked pretty well. Code listing 11.5 is one I like. 11.5, I declare a structure called date. I declare a struct called place, and I declare one called employee info. But notice what two of the members are inside of here. Two of my members are other structs. So now if I have something of type employee info, I would do dot birth date dot month to access the month. And if you look at the example over here, manager dot resident dot address. So I'm able to include structs as possible data types. Questions? Questions, questions, questions. No questions. I do like when there are questions. Okay, so here's what we're going to do today. Remember the program you did in the last class? You read in a number. It was the number of students. You had a loop after that. You read in that lawnmower guys here. Let me yell at the dog. Okay, so we're going to redo that from the last class, but this time you're going to create a struct. Now, what's the struct look like? Well, I want you to create a struct that would be of type student. Our array size that you're going to fill it with is going to come from that first number we read in. So you're going to have an array of student. The members inside of student are going to be name, test 1, test 2, test 3. Those will be read in. Finally, you're going to calculate the average and store it. So now that we're storing everything, we can display it all at the end. Make a nice little table. Read in the number of students, create the array, fill the array. Then go through and do the work like you did last time. That included finding the lowest test overall and who had it, the highest test overall and who had it, the average for everybody. I know that a couple of the solutions that were put on the discussion board, a couple of people were going, maybe that wasn't this class, maybe that was another class. It was another class. But I think there were solutions published. Any questions?